right, for these two volumes by revolution problems, we are going to set up the integral, and then I'm going to show you how to integrate on your calculator. So I like to draw the image first, and we've been working with this image already because we have y equals x squared, and we have the line x equals 2. So here's our y equals x squared, and here's our vertical line x equals 2. And now we are revolving, in this case, around the line x equals 2. So this is a boundary, and it looks like this is the region that we're going to revolve. And when I reflect that region, it reflects over to here, and I have these revolutions like that. This is going to be a disk method because there is no gap between the region that I'm revolving and the axis of revolution. So I just need my big R squared. This is going to be of the form big R squared dx. And actually it's not going to be dx because we are revolving around a vertical axis of revolution. So this is going to be a dy. Our limits of integration start here at y equals 0, and they go up to this point where the two graphs meet. To find that out, I plug x equals 2 into the function, and I find out that the y value is 4. So that's my upper limit of integration. So now the trick is to find my big R value. Big R in this case, because we're doing this with respect to a vertical axis, big R is going to be right curve minus left curve. My right curve is x equals 2. My left curve is the y equals x squared. So I have x equals 2, and then I can't put in y equals x squared because I need it in terms of y. So I'm going to have x equals the square root of y. I do not need the plus or minus square root because I'm only looking at the positive side over here. So my big R is 2 minus the square root of y. And the integral that I need to evaluate is from 0 to 4, and then 2 minus rad y all squared. And we're going to say dy there. And now let's work to put that into our TI. One way to do it is just to do the alpha f2, which gets us our integral, choice 4, and it gives us the integral symbol. So our lower limit is 0 and our upper limit is 4. So I type in 0, move up, type in 4. Now I need my big R, which is 2 minus rad y. I need it squared, so I'm going to open a parenthesis in here and say 2 minus, and then I need second square root, and I can't plug in an x, so I'm just going to go ahead and put in, I'm sorry, I can't plug in y, so I'm just going to go ahead and plug in x, which is fine. Excuse me. I'm going to come over here, does not want to let me do it. Let's delete that. Come outside the square root and close the parentheses. This is the piece here that I want to square. So I'm going to hit my squared button, and you can see that I have 2 minus the square root of x all squared. Then I need to come out over here and put in an x value. Now it does not matter that I used x instead of y. It just matters that I set up this function, or this right minus left, excuse me, this distance as 2 minus the square root of the variable. The calculator reading it as x is the same thing as us doing it as y. It's not going to make a difference in the value. So I hit enter, and it thinks, and it's going to tell me that the volume by revolution is not just this, because I also need times pi. I'm going to have times second pi, and my volume by revolution is 8.377 or 8.378. 8.377, or they will accept 8.378. They will truncate or round and accept either. All right, and now let's do D, which has us reflecting or revolving over the line x equals 3. So I'm going to draw my region again. My region is still this, but now the axis of revolution is over here at 3. So I have a washer method because there is, in fact, this gap here between my region and the axis around which I'm revolving it. So I'm going to need both a big R squared and a little r squared. So let's first start by finding big R. I find big R by taking the distance from the axis of revolution to the outer portion of the region, Remember, you always do right minus left if you're revolving around a vertical line. So I'm going to have 3, which is my rightmost curve, minus the square root of y, which is my leftmost curve. And then little r is the distance between my axis of revolution and the innermost portion of my region, which in this case is just 1. I am doing a y valued function here, or integral, because I'm revolving around a vertical line. So my limits of integration are still 0 to 4. I now have 3 minus the square root of y, all squared, minus 1 squared. So that's big R squared minus little r squared dy. And now I'm going to pull out my calculator, move it over here so that we can see what I'm trying to type in. And I'm going to start again with my alpha F2, go to integral here, type in my limits of integration from 0 to 4. And now I need to open with a parentheses. I then have 3 minus the square root of x. Oops, sorry about that. Doesn't want to get rid of my square there. There we go. Okay. Really doesn't want to get rid of it. Okay, 3 minus x, close parentheses, and square it, and then subtract out 1 squared, which is just 1, but I'll put the 1 squared in there just for fun. Apparently I should not have done that because my calculator does not like what I did. Okay, -1 minus 1 squared. Okay, and then we're integrating with respect to the variable that we input here, which is x. And I'm going to let it run here. And then don't forget we're going to have to multiply by pi because we are doing a volume of revolution. So take that answer, multiply by pi, and you're going to get 25.133 as your answer. And just to point out, let me go back to my calculator screen there. This one I could have done 0.132 because they will let me truncate it as well.